All right, everybody, let's recap the lesson. So today we're talking about how to graph parabolas. You know, those are the smiley faces or frowny faces using the zeros. So now zeros and x-intercepts are the same thing. So I've already graphed it. So I've got a 0 here and a 0 here, which are also x-intercepts. So the easiest way is we know that from the equation that the zeros, if it's in factored form, that the zeros are the opposite, positive 3 and negative 5. That's what I got on my Desmos when I graphed it also. And it makes sense because if I put x to be 3, 3 minus 3 is 0, right? And if I put negative 5 in for x, negative 5 plus 5 is a 0. So the zeros and x-intercepts are here. So now what I also know about this parabola is the line of symmetry is right smack down in the middle between the two zeros, okay? So I just found it, but if I have a hard time finding it, it's just the average. So if I take my negative 5 plus my 3 divided by 2, that gives me the average, puts me right smack dab in the middle. Now I know my vertex is somewhere along this line, so I took my negative 1, which is my line of symmetry, x value, and I plugged it into my equation. So when I plugged into my equation, and I put negative 1 here and negative 1 here, I wind up with negative 16, okay? All right, now with that in mind, we have a formula. This is in factored form. If you see the parentheses, 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 that's factored form, okay? So we know our x-intercepts or our roots are the opposites, right? So it's h0 and k0, whatever the values happen to be. In this case, it was 3, negative 3, and 5, which turned out positive 3, negative 5, okay? And then we also know line of symmetry is the average of those. So we just add those two and divide by 2, and we get the line of symmetry. Now, if we need the corresponding y value to find out where that is, you take this answer and just plug it in for x into your equation, and you'll get your vertex, okay? So we did another example. We looked at the factored form. We knew that the zeros, or the x-intercepts, are at negative 2, positive 4, because the opposites. I knew that the line of symmetry was the average, which is right in the middle, which puts us right here at 1. So I showed the average, negative 2 plus 4 divided by 2 is 1. The corresponding y value has to be along this axis of symmetry, so I plugged 1 into my equation for x. And I solved it. 1 plus 2 is 3. 1 minus 4 is negative 3. If I multiply, I get negative 9. So my vertex is at my 1, negative 9. My y-intercept is along the y-axis, and that's where x is equal to 0. So if I let x equal 0, I plug that in. I ended up with 0 for x, 0 for y, gives me the y-intercept. I get negative 2 times negative. I get 2 times negative 4 is negative 8, so my y-intercept is at 0, negative 8. Okay. On the back side, we did the same thing. The only difference is that we had a negative here, so we knew it had to be upside down. But let's just do the math, and we'll find it has to be upside down. So again, my x-intercepts, or my zeros, are at positive 1, positive 4, because the opposites. My line of symmetry has to be right down in the middle, which is actually at 2.5 or 2.5. And again, I can do the average. I can go my 1 plus my 4 divided by 2 is 2.5. My y value of my vertex is, I can plug it in, right? So somewhere along this line, 2.5, I plugged it in for x. I use my calculator, I get 2.25. So my vertex is at my 2.5 and 2.25, which forces it to be upside down. I knew it was upside down because of the negative here anyway, so that point actually makes sense to me. The y-intercept, I let x equal 0, plug 0 in for my x's, and I wound up getting negative 1 times negative 4 plus a negative makes a negative 4, which is down here at 0, negative 4. I didn't do example 4. That's a review of yesterday's. I didn't need to do that, so that's all I have from root form. Okay, so if you have any questions, ask me.